Hi, I'm Pei Shu Yu. Here's a microgrid designed for Weddell. Well, Weddell is a locality in the North Territory of Australia, located about 24 kilometers southeast of the territory capital of Darwin City. According to the city's plan, the west is mainly used for industrial development, and the land in the east is used for residential and commercial development. And also, according to the territory 2030 plan released in 2009, ultimately, Weddell is expected to have a population in order of 50,000 people. And as for the reason why I chose Weddell, well, it is because that Weddell is an undeveloped city, so it is significant to build a smart microgrid here. And in order to build it into a sustainable and a smart city, the microgrid can use wind energy, solar energy as power generation energy. And also, Weddell has sufficient renewable sources such as sunlight. So we divided Weddell into residential areas, residential commercial areas, industrial areas, and the suburbs. Then we use the microgrid with the 6-bus structure, and the amount of electricity each bus needs to supply mainly depends on the distribution of the number of people in each area. So the figure is the structure diagram of a microgrid. There are two working modes, excellent modes and on-grid modes. During the normal time, the microgrid can work at the excellent mode. There is seldom energy exchange with public grid in the mode. When the demand is too high for microgrid to sustain, the microgrid can purchase electricity from the public grid. Or when the electricity storage in the microgrid is sufficient, it can sell power to public grid. Let's be more specific. The node one, the area of node one is only for residential use. Due to the sufficient solar power in Weddell, the electricity generated by solar power can normally maintain the household use. So PV panels, here PV panels and battery are set to supply electricity and store energy. As for node 2 and node 3, these two nodes are for commercial and residential use. So we allocate PV panel and gas turbine generator to compensate the demand in peak hours. And meanwhile, the battery energy storage system is set to save energy. As for node 4 and node 5, these two nodes are mainly for industrial use, considering that the demand for industrial electricity may be relatively large. So it was decided to also build PV and gas generators, as well as battery storage systems here. As for node 6, node 6 is in remote area, so the demand is small. Considering that the wind speed in the suburbs will be greater than the average wind speed of the entire area, because there are more free open areas, a wind power generation system is established to utilize the wind energy. And because wind energy is relatively unstable, batteries are built to storage energy. In the mathematical model, we will consider several parts: the gas turbine generation, PV system, wind system, battery energy storage system, load, transaction mode. The functions are used to calculate the cost of each system, and we need to minimize the total cost. Here's the objective functions. And then we should consider the constraint: power balance, DC power flow, battery constraint, gas turbine, transactions. As for the next step, the model justification, well, we will estimate the load output according to power loads and weather parameters. For example, we get the temperature and the wind speed in Weddell, and so that we can calculate the PV output and the wind power system output. Finally, for optimization, we will use MATLAB program to estimate the most profitable, environmentally friendly option and calculate the improvement. Okay, thank you. That's all the content.